We should be live. Yes. Hey guys, thank you so much for joining this weekend. We are discussing on quite a few topics of AWS. First, I'll share the screen and then we'll go ahead with the topics. Let me share my screen. So that's my. This is an event which we're going to perform today. So we have piled up quite a few topics. Just wanted to quickly run through. So first we'll start with Anusha. She'll be introducing on the infrastructure as a code and the Terraform and how do we deploy to infrastructure and what is AWS Lambda. So it's like setting up the context for the next session. And the next session will be the Terraform. How do you deploy S3 as well as the object and S3 with the static website? So we'll be seeing those things, and we'll be working with Lambda. So what is Lambda function, and how do you create it with Node.js, and how do you create it with C Sharp, .NET 6? And then Jagdish will take over deploying the web API as a Docker container on uh, Elastic Beanstalk. So that will be the three sessions. So purely hands-on, less of a theory and more of a hands-on. And let me introduce with two speakers. Like three are from the same company and from the same team also. Okay, so let me introduce Anusha. Hey Anusha, welcome.
Yeah. Hi
And
everyone. Good morning.
yeah, and Jagdish. So,
Hi everyone. So, very good morning. So, happy Sunday and happy learning. So, hope you will get good information on these things like AWS. I think maybe
I think
Swami has lost his connection. Maybe
yeah.
Anusha, you can start the session.
Yeah, we will start. Yeah, let me share my screen first.
I think Swami garu, you were back. I think so. Previously, your screen was stuck.
oh yeah, actually, they closed the door. So router is on
Okay.
the other room. So I stopped getting signals. It's 150 Mbps speed, but because of Anusha, if you share the screen, I'll
Yeah.
flash it and then you can go.
Okay.
Okay, we're able to see. Over to you, Anusha.
Yeah. Hi everyone. Today we will first learn about what is IAC and what is Terraform and what is AWS Lambda. So let me introduce myself first. Okay. I am Anusha. I have more than 10 years of experience in IT industry. So I have mainframes background, and right now I'm into cloud technology. I'm also a learner. As you people are learning, I'm also a learner. So if I do any mistake, please don't mind. And I will take you only the introduction parts, and Swami and Jagdish will be taking you through the hands-on sessions. So we'll just first understand what are these topics today. So today we will discuss what is IAC and what is Terraform and what is AWS Lambda. Just we will see. Okay. Okay. What is IAC? Let me share. Yeah. What is IAC? IAC is it is infrastructure as code. The name itself indicates that you will define your infrastructure in code format. That means whatever the resources you need for your application to run, everything, all the resources, you will define in a code format. Uh, those code format will be saved in configuration files, and those files will be you will run them, and through those files you will create your infrastructure. That is the basic idea of what is IAC. Let us forget about all this theory part. So simply you will define what you want in the form of code, and that code will generate or manage all the infrastructure whatever you need. So before going deeper into how we do ISE, first we will learn why we needed this ISE, infrastructure as code. Why we needed to code our infrastructure in the form. We need to code our infrastructure in the form of a code. Why we need that? So in earlier days, actually, everything was a manual process. Managing resources and setting up servers, everything will be manual process. So whenever you want to update your application, or whenever you want to start any application, setting up these servers or setting up all the resources will be manual process, and it is time taking, tedious process. So because of that, the cost of the application increases, and also till the time you set up everything, your application will be down. So the availability is very during that time your application is not available. And also whenever you update your application, you may need to set up servers, and all this again takes more time and more manual power. So, and also one more thing is like, since multiple people are needed to set up all these things, so when multiple people are doing, and one person to person, the approach will change. So because of that, inconsistent issues will be there. So these are the main uh, challenges that were faced when we were doing infrastructure manually. So after that, we have come through cloud computing. Once cloud computing has come, many problems are solved, like scalability, availability, and also the infrastructure is all maintained in cloud. But still, we have to maintain those infrastructure in cloud manually. So to automate that, still we need a manual process in that. And still the inconsistency issues are there. Still we need to manage our infrastructure in cloud. We will manage because of that scalability, availability, all those things are there. And also speed of application deployments or anything are uh, they're all improved a lot. But still some issues are there. So to automate managing our infrastructure or resources, to automate or to avoid inconsistency issues, all those things we needed infrastructure as code. So when we write your code, when you write your infrastructure in the form of code, what it will do, you will define some templates for your application. So whoever does that in managing infrastructure, they follow the same template. So major of the inconsistency issues will be solved. And also you can automate your infrastructure deployments, like updating resources or all those things you can automate. And also speed increases, and at the same time it will all be done at very lower cost compared to manual process. So these are the things that led to ISC. All these challenges we can come over using ISE. That is the reason we are coding nowadays our infrastructure. We are using ISE. Okay, so how to do this ISE? There are two ways we can code our infrastructure. So one is imperative, and another thing is declarative. In imperative, we have to define each and every step. We have to define each and every step to tell the system what to do at each and every step for creating or for updating resources or for destroying resources, whatever it is. But in declarative approach, you define what are the resources you needed. That's it. You don't you don't need to tell the system you do this, you go to that place and do whatever you want. No need to tell anything, you just define the resources whatever you want, and system itself will take care creating those resources. So this is the example. This is imperative approach. See, if you see here, it is just asking it each and every step, if something is there what to do, if it is not there what to do, where to create, where to go, all those things we need to define. But if you see in declarative, we just need to define our resources, and we don't need to tell how to create those resources and all. So the system the system itself will take care how to create those resources. So there are many tools actually available in today's market. Many tools are available to create IAC. So these are the popular tools nowadays we have in market. So Terraform is one of them. Today we will talk about Terraform. So what is Terraform? Terraform is HashiCorp's infrastructure as code tool. So it is also an IAC tool, and it follows the declarative method of coding, and you declare the resources whatever you want in the form of configuration files. So you can save your file in any format like JSON or any format, and you save them, and you have to follow some structures. So see, here it is, here you write your code, and you need to just follow 2 to 3 steps. They are just a command execution, we will see them. And once you follow these steps in cloud for platform, it will create your resources. So this is the basic use of Terraform. But compared to other ISC tools, Terraform has many advantages. The main advantages we will say. So first thing with Terraform, the advantage is like Terraform, it supports multi-cloud. So you can use Terraform for Azure, you can use Terraform for AWS, or you can use Terraform for GCP. So it supports multiple cloud platforms. And also the code will be in human readable format. That is very important, because if you write any code in your team, if they want to use the same template, they will be understanding, anyone can understand easily, and they can follow the same. So this is the advantage of having a human readable format of coding. And also this Terraform allows you to track the resource changes while deploying. So when you are doing the changes, at what state your resources are right now, you can track through that. So that is one more advantage of it. And also you can do a version control of your configurations. That is another main advantage of Terraform. These are some of the advantages, and there are many other advantages. And mainly compared to other ISC tools, mainly Terraform generally used by the people who are doing these infrastructure from scratch. In those cases, it is more useful. See, this is example of how Terraform looks like. See, if you see here the provider, here I have defined the provider as AWS. That means this Terraform is going to create resources in AWS, and these are the resources, and just you are just declaring whatever you want. This is how a Terraform code looks like. How it works. Terraform, the core Terraform workflow is these 3 steps: write, plan, and apply. When you write, first what you have to do, we have to code our infrastructure. So the write is what you write your Terraform. Plan is what? Plan is like you review the changes whatever you are going to do to your resources. Those changes you just have to review before you change the resources practically. So plan is where you review all the changes of your resources, and apply, it will actually create your resources, or if you want to destroy or update whatever you want, this apply will make the changes to resources. These are the core workflow of the main workflow of Terraform. And in general, the workflow of Terraform will be like this. First, what you do, you first write your code and initiate it. Initiate will actually download the requirements you have given in your template. It will just download whatever it wants and keep everything ready. And plan is where you review all the changes you are going to do to your resources. And apply is where when you whenever if you are creating any resources, it will create those resources, and if required, then you will destroy the created resources or infrastructure you want, if you want to. So this is basically what is Terraform. So now we have seen what is ISC, and in ISC we have seen the declarative format of coding infrastructure, and in that there are many tools, and one of the tool is Terraform. So now we have seen what is Terraform also, and today we will see what is AWS Lambda. AWS Lambda is nothing but just a function. If you see, like it is a block of code. Okay, so where if you see the definition, it is like compute service which will run without managing any servers or any infrastructure. So first, before going to see what is AWS Lambda, first we will see one use case. Okay, suppose a user is uploading photos. The user has uploaded one photo. That photo we have saved in AWS S3 bucket. And what the user expect is immediately the photo she or he needs to use as a DP or profile picture, whatever she wants. So for that we need to process the photo which was uploaded and keep it ready to be able to use by the user. So for that what we need one block of code which will be run to process that image and make it ready. So for doing this, so whenever the user uploads a photo, that function has to be run, that code has to be run. So if you see here, here it is looking like a event driven. Like whenever the user uploads a photo, the code has to be triggered and the code has to be run, executed, and then that output will be available to the user. So it is like triggered, event triggered. So Lambda is like a code you save in your file, and whenever you configure it, it is available. So it is event driven. You don't need to keep it available, or you don't need to maintain any servers or infrastructure for this. Okay, you write your code and configure, and it is event driven. Whenever something happens, that actually triggers your code and the code executed, and you'll get the output immediately. So that is the main idea of AWS Lambda, and the advantage is you don't need to you worry about the infrastructure, like whatever the resources needed for for running that code. You don't need to worry about it. That AWS will take care, and also the instance can be anything. Like if there are multiple users, there are millions of users uploading photos, and millions of instances of your code will be run separately. So that that loading, that scaling will also be done by AWS. So you don't need to worry about anything. You just write your code, configure, and see it. Everything will be handled by AWS. And also the cost is also very less. Like the cost will be calculated based on milliseconds. So and how much time your code has been run, it will be computed based on millisecond. So how many milliseconds your code has run, for that time period only you will be charged. So it is very cost effective also. And whenever you, if like this, whenever you want any events, have for any event, if you want to run any code, you can go for this AWS Lambda and write your code. And there are many advantages of this. We will see what are the advantages. You don't need to manage any server. You don't need to manage any server. Okay, that will be taken care by AWS and continuously. So sometimes you will get more users will be running this, and there will be some days where less traffic will be there. In that time, that scaling will be taken care by AWS. And millisecond metering is like how I said now, it will be based on milliseconds. So if 10 users are using your code, so how many milliseconds that code has been run, and also number of times the code has been run, based on that you will be charged. So it is very cost effective. And also, since you don't need to manage any servers, you don't need to worry about anything about the infrastructure, so you can concentrate on coding and you can increase your innovation. And also in AWS Lambda, it is having some built-in AI models, so you can use the models and you can modernize your applications. And also rich ecosystem it provides. So just by using AWS Lambda, it is like you write your code and sit, configure it and sit. Everything will be taken care by AWS. So it feels good, right? Just concentrating on code and sitting, and will be taken care by the third party every time. So we can concentrate on coding more instead of infrastructure and other things. This is the main advantage of AWS Lambda. So yeah, this is what introduction today. Passing on to Swami Garu. Swami Garu, you are there? We will wait for a couple minutes. He will come. Yeah.
Hello. Hello.
Swami Garu, I am done. Actually, waiting for you.
Oh, okay. Okay, cool. Thanks. So let me share my screen. Just a glass of water. Okay. So are you able to see my screen? Jagdish Sharancha?
Yes, yes, we will.
Yes, yes.
Oh, okay. Okay, cool. Thanks, guys. So this is my I will put it here in this one. And today's session, that's particular code will be here under this. Okay, just in case you guys want to very quick hands-on on this one, this will help. So what are we going to discuss today? There are quite a few things we have piled up today. So I'm still going to do today. Sorry. We're going to create S3 bucket and an object using Terraform, and then like this, and we'll access that particular object. So this, why are we doing is, when you compare in the previous session when we created the S3 bucket and objects manually using the AWS console, because Anusha, Jagdish, and I, we three are from the Azure side of the world. So we wanted to be a multi-cloud folks. So we started learning this AWS. So sometimes we might use the words which is from the Azure side. So in Azure we call it as a Azure portal, but here in AWS we call it as a console. So even if I call it as portal, understand that it's some referring console. Okay. Similarly, virtual machines in Azure and EC2 in AWS. Sometimes I interchangeably use because working in both sides of the world. So that's one thing. So we know how much time it used to take when we go and create it here. So we need to go and create, we need to add the permissions and all those things. And the second thing what we will be focusing today is, uh, the second thing we'll be focusing on that creating a static website. Like how do we go and enable this static website? So that's the first one. Is just we'll create a S3 bucket and upload a simple product object, the PNG, and we'll access this. And then we'll go ahead and create this S3 bucket and a static website. So we'll see one code which I want to specifically emphasize here. That's a little bit different. That's the only catch there. Apart from that, everything is pretty straightforward. So you can see that you'll be uploading with the S3 bucket, and here is the AWS static website. And then next thing what we will do is is that only HTML, JavaScript, and CSS, the static website you can do it, or something like a Angular or Blazor WASM? I thought of to showcase Angular 12 and Blazor WASM, but I thought Blazor WASM I'll show it next time, because so that I can accommodate more of a AWS Lambda. So we'll execute this locally, and then we will upload that. This is manual, because we can create, technically we can drop all these files. I'll tell you what is that we need to take care when we are uploading. And then we will come to, Anusha has already introduced what is AWS Lambda. So we'll do two small or two mini projects. One, we'll create a AWS Lambda and console, and then we'll see that how can we test it. Some of the things which we'll go and explore. Okay, what is that we are going to get it? I mean, this is introduction. Again, we'll visit for rest of the year. We'll visit creating a lot of lambdas and beanstalks and different services like DynamoDB. Now, this is simple hello world or introduction to AWS Lambda. How do you create it with Node.js, and how do you create it with the C Sharp? Anusha, Jagdish, and I, we three are from the C Sharp side of the world. So we'll try every now and then. We'll see if we can showcase one Java, JavaScript, or Python or Go. We don't know at this point of time, but we'll see as and when we get some source code handy which we are able to, then we will showcase that one. So this is the first one. This is how do we trigger the destinations. We'll come back, but slowly, this is the first one. We'll create it with Visual Studio 2022. We'll test it locally with the local test tool, which is coming by default from AWS toolkit. And then how do we deploy this? How do you deploy this Lambda function to AWS, and how can we test it? Okay, so next, what we will do is in the next month's episode, we will be working with S3. Now, what if someone drops a file in an S3, it gets triggered. And what if we call an HTTP Lambda function? It should go and write the rows into the DynamoDB. So now, this time we are introducing what Lambda function and how to do a hello world of the Lambda function. But next is what you'll integrate the Lambda function with other services in AWS, like S3 buckets and DynamoDB. We'll see what else can we integrate or incorporate. Okay, that being said, the first thing is, we'll please fasten your seatbelt. I just want to show you a couple of things. So for the state maintenance, I'm using this Terraform workspace. Okay, I'm using the Terraform workspace, and this is the workspace which I'm using, where it maintains the state. Instead of, imagine a scenario where you're working in Azure or AWS or some other cloud, one specific cloud. In that case, it makes sense that you store the state inside the same cloud, maybe Azure or AWS or GCP, whatever is your cloud. And you're using only one particular cloud. So it makes sense to store your state of this Terraform configuration inside that cloud provider. Imagine you're using multiple cloud. So you're not you're not going it with one specific cloud provider, but you're working with multi cloud provider, because the solution is pretty enterprise grade plus kind of thing. So you need multi-cloud for disaster recovery, or some services in cloud A and some services in cloud B, something like that. So in that case, it makes sense to store this state in a centralized location. So Terraform Cloud provides that. This is a free account. As you can see, this is mine is a free account. So, but still, we have a lot of facilities here where we can store and we can see that what happened, how the state is changing, and when we terror out. A lot of things are here. You can see that. We'll see this in action in a couple minutes from now. Now you can see that I have these three of this S3 buckets. And one thing to notice is, suppose if I am going to Lambda, if I'm going to this Lambda or EC2, I just want to show you one difference. Maybe you guys already know, but I just want to highlight this one piece. Like if I go to EC2, I can say that give me all the EC2s in West US region. So this guy goes and picks it up, all this why is this?
Yeah, your voice is breaking. Thank you.
It's 150 Mbps. It's 5G internet. Now, Jagdish, it's
Yes,
fluctuating. Maybe they are
yes, yes.
pushing some hardware,
Maybe,
firmware.
maybe.
Yeah, looks like they're.
So
Huh?
you're not like so where you were
Maintenance as well.
staying right now.
Yeah.
You said you were in a
So
different
it's
room, so where the network is not that much.
right. That's what I'm saying. Better I will move to the same room where the net is there. I think that will be much better thing to do it. So I'll go and move here. See this here, it is bumping up. Right. You see this here, it is 92. There it is only less than. See this? Okay. Thank God.
It's good now.
Yeah, it's 150 Mbps. There it was coming in that room. I think this is not catching up. I need to check with these folks why it is not catching up. It's 150 Mbps. In that room, I'm getting only 8 or 9 Mbps. Okay, never mind. Now this is good. So now if you see this, if I go to this AWS Lambda, or if I go to this EC2, those are very specific to a region. Like if I come in here, US East 2, so that means it is going to give me those EC2 instances which I have created in that particular region. So some of those services are very specific to the region. You can see this, there are 5 instances, but none of them are running as of now. Similarly, you can see this Northern Virginia, East US 1. None of my Lambda functions are running. Jagdish, I'm, I'm feeling to call it like a Azure functions because you're from the Azure side of the world. So jokes apart. So there's nothing in here, and you can see this the state and the runs. As of now, the previous run got failed, which I tried it 11 hours ago last night. Around 11:30 I was trying this, some experimentation. Okay, so that being said, let's come back to the first topic of today. You can get into this infrastructure, and this is Terraform files. So you can go and check what version of Terraform you have. Like if I see Terraform version, so right now I have 1.2.8. So last night when I tried, I think if I'm not wrong, this Google Cloud supports 1.2.7, but I bumped it up to 1.2.8. Then I bought it back to 1.26. I bought it down to 1.26. I didn't. I tried it with 1.28. This one 1.2.8, but it didn't work out. So I had to bring it back to 6, or it should be 7. Here, whatever this cloud supports, it supports 1.2.7, but I had 1.2.8. When I use it, it threw an error. Okay, that being a side note, let's come back and see that I have a couple of variables. One is the region is West US, and the root domain name is 3 bucket dev 1, and the subdomain is the first portion of that, the fully qualified name is eShop. And outputs, what I'm showing is I'm showing that the bucket eShop ID and all the tags. And it's pretty simple, like this a Terraform block where you say that what is the provider, and and then any of the configuration, like it should be in that the same region where we mentioned it, West US 2. It should be from the same region, and it should be in the same region, and this is the bucket name, and the bucket name, and this is the access control is public read for that, and we are uploading this object from our local machine, so that is under this folder, content folder. The product one is under the content folder, and then this is a policy we are saying that allow everyone. So now let's go ahead and create this cd infrastructure, and cd a1, and then let's try this. Okay, so let's do first thing is Terraform init. So why are we doing this? As Anush has already set up the context, like if I have to do this, I need to come and click on create bucket and give its name and select the region and the access control list. I need to specify and what should I allow, what I shouldn't, and I need to specify tags and other things. If I need advanced settings, I need to create an advanced settings, and then I need to click on create bucket. And once it creates the bucket, then I need to get into that particular bucket. I need to get into the bucket and get into that particular folder. Okay, and then I need to click on upload. So this much of manual process is there. Instead, we can do it pretty quickly through this in, through some kind of automation. Maybe you're using Azure CLI or AWS CLI or PowerShell or Cloud Formation and ARM templates or biceps and Terraform. As Anusha mentioned, there are a lot of tools and services are there which helps you to do it, but we choose Terraform because the same Terraform skill set we can use it in AWS as well as in Azure. So it's like a cloud agnostic. So learn one technology, use it at different clouds. So that's one more reason for us to learn this Terraform. So then I do Terraform validate. So when you do the Terraform validate, it goes and validates just the syntax. So sometimes what happens is Terraform validates will be success, but when you do a Terraform plan, it will fail. Okay, so I just wanted to show you that. I will show you when we are doing this one, and then we will do Terraform plan, and then it executes this. The Terraform plan will execute it, and then you can see that one more thing to observe here is at this point of time, inside the Terraform block, I don't have the backend. That means the entire state is stored in my local machine. The entire state is stored in my local machine. If something happens to my local machine, the state of this set of infrastructure is gone. So it's risky. Now I'm doing Terraform apply. Terraform apply auto approve. So when I do this, it starts creating the resource. In You can see that it clearly says that the symbols which you see here, that shows that whether the resource are getting created or modified or deleted. So there are three symbols at a high level which you can understand. Is one is plus, means it is adding that infrastructure piece, and tilde means it is modifying. minus symbol represents it is deleting it. As of now, it is creating. It's not deleting anything. Everything is create. So it has created. Now, if you come back to the AWS console and go to S3 buckets, now you can observe this. Here, it has grayed out all these things. It has grayed out all the regions. So what do we understand with this is we understand that the S3 buckets and objects and other things, they are global service. They don't belong to one particular region. We can see that the S3, it says that it is global and it doesn't enable any of those regions. But if you see this Lambda functions or EC2s, we can see that they belong to specific region. So it means you create a Lambda function or EC2 in Azure world, we call it as virtual machines. Here we call it as EC2. If you create EC2, that belongs to that particular region. So S3 buckets is global. And that is the reason the SLA is such good. So you can see that I click on this and I click on, will be here. This is an object URL. I take this object URL and just I'll post it here. If anyone would like to try opening it, they can open that. But I can also come in here and click on this. So that has downloaded this product image, the product one image. Okay, that was our first assignment. And let's go to the second assignment. But before that, I just wanted to show you that previously we saw that the Terraform state, everything is maintained here. Never ever check in Terraform state to the source control because it has got some of the key pieces which might turn out to be dangerous for you people if you save it in the source control. So please ensure that you're not saving it. And I say that destroy because I don't need now these resources. I am destroying it. I'm going to another console so that we can speed up the task. So the next thing is I'm saying infrastructure and go to the second sample. And again we do that Terraform init. So it initializes that. Now you see this Terraform state. If you see, there were large number of rows were there, and that has been transferred to this Terraform backup. That happens in local, and when you come back and see this Terraform state, that will be nullified. Now you create something, then it maintains this Terraform state. That's how it knows that what is the state and what it should exist on the cloud side of the world. Okay, now that we have created this, and let's come back and go back to the buckets and let's see, it should start destroying this resource. Yes, it destroyed it. That's good. So let's do similar two things. Terraform validate. This I told you, isn't it? I want to show you that the previous step doesn't guarantee that the next step will work. If we do some mistake, it's not others' problem, isn't it? The Terraform is providing us tools and services, and if I do some mistake, then it can't help. It can't go and help saying that I will go and create even though you did mistake. So let's do the same mistake, because here if you see that Terraform block, I'm saying that cloud, the organization, if you see this over here, this is my organization name, Swami the TF learner. That's the organization name. And what is a workspace? First simple workspace. That's the name I've given, the first simple workspace. So I'm saying that provide store the state of this particular, I mean A1, the first sample I didn't store anywhere, it is local, and now we are storing it in Terraform cloud. We can technically store it in AWS or Azure or any cloud provider. We can store it, but wanted to show you one more thing. We can store it in a Terraform cloud, a centralized location. If you for multiple reasons, you shouldn't store any of the state in local machine. That's for sure. And if you are having a solution which is from multi-cloud, so it makes sense to store it in a centralized location. That's one motivation. Now let's assume that if I bump this up to 28, now you can see that the validate is success. Now I can show that after 1.2.8, when I do validate, validation is success. But you can see this, what Terraform supports at this point of time is 1.2.7. Now if I go and try to do Terraform plan, when I go and do the Terraform plan, it should technically fail. It started the plan. We can go and check over here. It says that failed. This configuration does not support Terraform version so and so. To proceed, either choose another supported Terraform version or update this version constraint. So that's what it says that 1.2.8. No, the Terraform Cloud, it supports 1.2.7. So the key thing why I wanted to show this piece is I want to show that even though the previous step is success, that does not guarantee that the next step will be success. Now that we saw the validate step was success, but the plan state was a failure because of some other mistake which we did it. Now that we fixed it, now let's go ahead and do a Terraform plan. When you do the Terraform plan, now this time we can come back over here, and as soon as it starts the plan, you can see that there's a plan which got queued. This one also errored out. Now this is where you can see that you can get into that. Now it's starting. So the execution is remote. You can see that whatever happening over here, you will see the same set of changes to output, same set of logs here, because the execution is happening on the Terraform cloud, not on your local machine. Even though it executes on your local machine, but everything is getting maintained here. Technically, it is called as remote execution itself. It is displaying the logs on our local machine, but you can see that the plan has finished. You can see that the plan has been successfully finished. That's one good thing. Now let's come back to the overview. It should specify the last run or all the runs. This has errored out. We don't need to worry about it. That was my mistake when I did that error. And then the next thing, what will happen is you can see that eShop static website, and the name is S3 bucket eShop. Those are some of the tags which I created. Now I go and approve. Sorry, Terraform apply auto approve. Okay, Terraform apply auto approve. Now you can see that here it doesn't maintain any state in local. It maintains everything. You see this preparing the remote apply, waiting for the plan to start. You can see that a lot of these things it will give you information, and additionally you can come to the centralized location, and you can see that the previous run was planned and finished. So now it is executing the Terraform command. That means it is applying the infrastructure. Now it has started creating those infrastructure in AWS. Now you can come and give it a few minutes. You can see that the changes to output. It says that these are some of the changes which will be applied, and you can see that it started creating, and then it has created everything. So now you see it has given the endpoint here. So how did I get the endpoint? The endpoint is AWS S3 bucket website configuration dot eshop dot website. So each of these individual identifiers are a resource in the main file. So how do you know that? If you start minimizing these blocks, you will see that. So this is the bucket name itself. Okay, and this is AWS S3 bucket website configuration. This resource itself is a website configuration. Okay, inside that there is something known as eShop. So that's what you're seeing, that S3 bucket website configuration. That's the resource name. Dot eShop is what? Is the name of this resource. It's like a variable name for this resource. This is the name which we are giving it. And then we are saying that website underscore endpoint, that gives us this entire endpoint. Now I can come in here and go and check that. And, let me copy this endpoint. We can technically get it from the AWS console also, but I thought this is spitting it out when it is local. So you see this? This is a simple website which is of HTML, CSS, and JavaScript. So here is the content within this folder, and you have scripts, JavaScript file, and styles folder. You have this one, error HTML, index HTML, and favicon. That's there in the content. So from this entire Terraform configuration file, there is one block which is very, very important, which I wanted to highlight. So here what is happening is, when you upload each and every file, you should specify, because this is happening through the program, through programmatically we are doing it. Suppose you do it through the console, AWS console, it recognizes what is the type of file you are uploading. But when you're doing it through programmatically, you have to tell that what is the type of content it is. So that's the key thing. So the content type. So this block, AWS S3 object, that block, only these two lines are very, very important. So here is, we are saying that in that directory folder, that means in content folder, if you come to this variables, we have specified the upload directory is content. That means within this file. That means we are executing a for loop on all the files, star star slash star dot star. That means within that content folder, any subfolder, all subfolders and all files. That's what it is. And we are saying what is the bucket ID and what should be the key. Key is for each of the elements, for each of the file and folder. Technically, it get whatever it gets updated, replace that directory. That means if the folder name is assets or scripts or styles, so in content slash styles, content slash something, so we are excluding that content slash, and that's the name of the asset, whatever we are uploading, that's being given as a key. And the source, we are telling that upload folder plus each value, that is the file. And then e tag file MD which we are generating. This line is very, very important. So we need to specify the MIME types. So for that, what is happening is, within all the values, we are splitting the dot. That means file name A dot extension, B dot extension, C dot extension. So the dot is there. We are splitting A and the extension, and we are taking the extension. So you can see this in the variables. We have specified the MIME types because my sample has got only few things. Wow, what are the things? JSON, .js files, .css, .html, .ico. So ICO is image slash icon. HTML is text HTML. CSS is text CSS. This is application JavaScript. So it just splits the name of the file. Okay, it splits the name of the file with the dot and then -1. So that means index 0 and 1. So but the length is what? 2. Because when it's split, the array will have two elements. So 2 minus 1, 1. So array of 1 is the second element. That means the extension. So look up for that extension. So when we do a lookup for that extension, if it is ICO in this map, it gives image slash icon. That's the only catch there. Okay. So now that we understood this to a decent extent, let's go and execute the Angular 12 app on our local machine, and then we'll upload it manually. Okay, there is Uh, this one which I created last year, July. It's more than a year, more than 1 year. Okay, let's minimize that. You can see that NG12 products. That's Angular 12. And when I come in here in the Angular JSON, ps config that products. It's under dist ng12. I'm sorry, ng12 underscore products because that is in Angular 12. So this is the one output part. I just wanted to show you that. So when we do the compilation process, when we do the build, so it goes and updates this ng12 folder inside the dist. So that's technically this block or this particular folder. Let's go and reveal in File Explorer. You can see the timestamp. Last night I was trying this at 10:57 p.m. Okay, so now we'll try this real quick. So, a simple hello world which I learned it from plural site from Deborah Kurata's Angular course, Angular startup. It's a very nice 5 to 6 hours course. I really liked it, so I learned it from that course. This one last year. Let's execute this. I have a README file here, and we need to have the JSON server. So this JSON server is the temporary or a mock API where you can have a folder based database kind of thing. I mean, the file base, like this is products.json, it has got all of products. So technically, we can do everything, CRUD operations on this one, and searching. A lot of things are there uh, in this JSON server. I really love it because if you don't have your web API ready, still you can go ahead and start this JSON server. I need to be in a command line for that. cd web API, and I execute this. Let me delete that. Let's wait here for 1 minute until this, you can see this, that's the resources. But if you get into this JSON server NPM package, so you have a wealth of knowledge where I can click on this. Technically, you can see this. It displays all these products. Okay. Now, suppose if you want to go ahead and get this single product, we can take that and add it at the end of this, and it gives you a one single record. So it's technically the web API itself, but the heavy lifting is done by the JSON server. So that should be on for us to go ahead. And then the next thing is I'll start the web app. That's the same simple web app, npm start, and you can see this npm start. It's doing ng-serve-o. The version is somewhere between 12 and 13. It's not 12, it's 13. I think I didn't bump up to 14. I thought I bumped it up. So from 12, I bumped it up to 13. I thought I did it, but I slipped it. I'm sorry for that. It's Angular 13. So let's take one quick minute before it starts. In the meanwhile, let's make ourselves some prep work for this. Let me get into this. And these are some of the files. I just want to take some risk. Let it be, whatever it is. Wow. Really? You can see the logging, whatever is being given here. It's pretty much lot of things they are giving here in the logging. What is that? See this JSON server. You come to the main folder, it gives this JSON server and resources, how many resources you have exposed, and it says that what operations you can specify: get, post, put, patch, delete, and this one. And also you can get deep into the weeds. You can go to the JSON server documentation and can do a deep dive into that. Okay. Hope this has compiled. Wow, it's compiling. Is that my machine is slow? Could be. I'm not sure. It could be the machine itself. Let's give that one more minute so that it will compile. Okay, it is there. We're here. So I click on this. Uh, you come and see this. It's a small, a simple. I mean, I was practicing Angular, so you can go to click on this links, and I click on products. So there's a small spinner, and you can go and do all these things. This is a simple site. So at this point of time, the site is being executed in the localhost, this web app. So what I do is I just go and turn it this and npm run build. Okay. So when you do an npm run build, that means npm, it's running the script build. Technically, it is executing ng build. You can see that it executes the ng build. And we'll come back here, and you see this in the dist folder, the ng12-products, that folder, it has nuked it, it deleted it. Now it is going to create it afresh. It's going to create these binaries. It is building. You can see that it has removed it. See, now it is creating this one, and you can see the timestamp. Previously, when I showed it, the timestamp was 27. So that same thing you can see last night when I was testing this before the show. You can see this. It is around 11 p.m. I was trying this last night. So now you can see the timestamp is this one. But the fav icon is the one which tells that this project, whatever I was learning from Plural Site video, is in July 2021. See, this rest of the file timestamps is all latest, but this fav icon is from July 2021. There's a 1+ years old, this one. Okay, so now it built it and it compiled, and you can see this, the size of all those artifacts is very, very small. So one thing what we can do is, I'm taking a little bit of risk. Technically, last night when I was trying, I deleted everything from this and then I uploaded the new one. But today I just wanted to take the risk live. If it is failing, it will fail. Even I will learn that I need to delete and upload. Let's try this. So let's do the upload. This is an experimental thing. If it fails, it fails. So first I click on add files and come to this folder, select everything except the assets folder. Now I do this. Now I say add folder, because assets is a separate folder. It has got its own set of files. So I'm uploading all those things, and I click on upload, and you saw that where did we created? Here or here? Yeah, this was the site, previous site. So this was the previous site. Let's check that did it upload. So still it is uploading. Let's see what happens if I try to access this site now. Ooh, it's transforming to Angular. There you go. So see that. Okay. So you don't need to delete. It will work. So I can technically click on products, and is it going to locate the files? We'll see that. If it is not locating, that's fine. See the funniest part, folks. You observe this website, it has been hosted in AWS. I want to show you this. You will laugh like anything. I mean, I myself was laughing when I saw this behavior. Let's go to the network tab. And I don't want the. What is that? Ah, God, this guy is struggling. Now, let it be. It's not going to help anything. I will delete that. Let me go to the home page. And now I click on products. This is the products. Where are you getting these products? The products is coming from one of the website which I have hosted. Okay, it's already there. So see the thing. The API is in Azure and the web application is in AWS. Now, multi-cloud scenario for some reason, maybe two companies has merged or something. They have services in one cloud and you have services in another cloud. Now you do integration seamlessly. Now cloud to cloud. There's no one is stopping. Like from AWS, the Angular website is in AWS. That is hitting the web API which has been hosted in Azure. It's .NET 6 Web API in Azure and the SQL Server is in Azure. Now, this is multi-cloud. So that's one of the motivation why did we choose Terraform. Okay, so that's another part of our exercise. I think Anusha would have given a uh, uh, decent introduction on AWS Lambda. It's a serverless computing. The word is little bit tricky. Serverless means that does not mean that there are no servers. The only thing is you don't need to worry about servers. Okay, you don't need to worry about the server. And one more thing, it's just a consumption model. How many times you hit that function code, so those many times you'll be charged. That's the only thing. Apart from that, a lot of things are there. This is just the first session. We'll again, time and again, if you see, S3 bucket we introduced in the previous session. I don't know when did we do that previous session. But in the previous session we did S3, at least for two sessions we did about the S3. Now we were doing everything manual. Now if you see that, how many things did we achieve when we go to this Terraform? We didn't worry about adding the tags and other things, and we didn't worry uploading the file, go clicking on the menu, click on the box, it comes, go and choose the folder. No, nothing, put it there and everything gets deployed within fraction of seconds, and then you go and access it. Maybe it takes 1 or 2 minutes, but imagine a scenario when you go ahead and delete, because we added some other files. That's the reason it is this is failing. This is the reason I was telling that. Okay, that should be fine. I will delete it manually. Okay, now let's come back to the Lambda world. Let me go here and go to this bucket. The simplest thing to delete is just select and click on empty. And one small tip, whenever you have to type something, you don't need to type, you select it, hold the control and drag it. Okay, you don't need to do copy paste also, just select it and hold it and drag. And go delete this. Now, come back. Okay, let me select this and I click on delete. And now the bucket name is, again I do the same thing. I select it and I'll drag this. Okay, you don't need to type all those things. Cool, that's done. Now let's come back to this Lambda function. So there's a lot of things, but we'll see how best we can do this one. So let's create first one. But at this point of time, guys, as I was mentioning, let's make our feet wet and hands dirt on this one, and then we'll come back, like how we are revisiting S3 bucket for the third time. And again, next time we will do some more things, like it's an integration between S3 and Lambda, and then it's an integration between S3 and Lambda and DynamoDB and Lambda. So a lot of things will come. So it's like a integration of this Lambda function with multiple services. The Lambda function is not over. We might go till 5 more episodes or 6 more episodes. The number of episodes is not important, but the learning is more important. So we'll see that what all the things we'll learn. So first we'll go. We can create the Docker images. We'll definitely come back and browse serverless app repositories and other things. We'll see the blueprints and other things. You will be overwhelmed to see when I show something in the Visual Studio. So let's see this. We call it as greetings or hello world. That's the technical thing. So here you have the runtime. So you can use .NET 6, .NET 3.1, and when you say .NET, it is only C# or PowerShell. Now you can have Golang, Java, and that is Corato, Amazon's this thing, uh, Node.js, Python, Ruby. So there are other things also it supports this one, but let's go ahead with this one particular thing, and I'm selecting the permissions because this is very key thing. Either it creates a permission or you can use the existing one because I already have. I'm using this existing function, and I'm not choosing anything in the advanced setting. We'll again come back. Like if you want to use it, we'll use the enable enable this one, enable function URL, which you can hit this function through HTTP. That one thing I will select it. The course origin is when you want to hit it from the JavaScript. I just selected it, but we'll come and discuss about it later. But we have two different things to do. So first we'll do the Node.js one, then we'll do the C# one. Okay, so now that we have it, it has given some JavaScript code here. Now again, we'll come back on what event did we select and other things we'll come and learn in the next session. But today, let's do it blindly. Okay, whatever it is supporting. And I want to test this. You click on this test, create uh, test func. Okay, and that's the name hello world we have given, and this is the input. Let's assume this is the product ID A101, and the product name, that's a product ID, and the product name, your phone, and let's say price 1.1, this one. Okay, that's the one, and we click on this, and we'll come and do a deep dive later, guys. As I was mentioning, first let's see that how does it work. So when we click on this test func, it got the response, and we got the response. It's like a get method kind of thing. Now you can come back to this index, and another thing is what is this event. So you can write this console.log and search for event. So let's see what is that which is there. So click on deploy. It deploys the latest changes, and again click on test. You see that this log statement over here. That's what we did, console log. So okay, so whatever the object which we are sending it as part of our test, that entire object it is spitting it. So ID, name, and price, or P capital. Oh Christ, I did some mistake. No problem. So now if I do a few other console statements, console.log, and I am going ahead with this, and I'm saying the ID, and you can see that event and event.id, and then name, event.name, and price, event.p capital. That's my mistake. I did that, and this is dollar, and that's dollar, not hash dollar, right? So I deploy these changes, and can see that. You see nice, beautiful statements. Log, you can dig deeper. Now, this object, whatever we are sending it, that itself is this. Instead, we can send this entire object, whatever we are sending here, take this and send that and add this. Hello, Lambda. Okay, deploy that. We can send object and we can do everything. I mean, see that in the inside the body, hello Lambda, and all the object. So you know that one what inputs you're getting, you can do console to identify how can you split it, and then you write down the processing logic. Okay. Another thing is you can go ahead and see this the configuration. We enabled the function URL. I thought that we will discuss about this little later, but now that we touched upon, we can see that all these things are undefined because we didn't send anything in the body technically. Good that it's not failing. I thought it will fail, right? So we didn't send anything. So those objects has been coming as undefined. Again, we can write more and more logic on this one. Okay. Now the final piece of the demo is like we saw that how to create a simple Lambda function in Node.js. We didn't discuss about the triggers and anything. We just did something. We created a Lambda function in Node.js and we learned something that the inputs, whatever we receive in this event object, and we know how to get into that object and how can we modify the response object which is coming out of that, and how can we go and access the Azure. I'm sorry, that's what I told. We are from the Azure side of the world. We always use the word Azure functions. AWS function URL. How can we do this? Okay, now let's create this Lambda function in Visual Studio 2022. Okay, so I'll keep this as a reference because anytime the live demo is not working, I can fall back on this, right? So let's create a new function. So here there are host number of options. We go with the one simple option as of today, and then we'll revisit. So you can see this templates, AWS templates, and AWS serverless application. That's the one you have it here. AWS Lambda project with test. There are a lot of things are there. AWS function project with Node.js. We will take this one. Okay, AWS this one, we'll take it. AWS serverless application. We'll select this and let's go ahead with this one. And we'll call it as hello world, right? That's what I'm calling it as. Now go create, and here that's what I said, that when I saw this option I said wow, so many options. So it gives us ASP.NET Core web app, the serverless, and annotation framework, minimal API. Lot of things are ASP.NET Core web API. A lot of things are coming in. I'll choose this one, empty serverless application. Let's go ahead and create this empty serverless application, and there you go. It comes into this one, and we'll touch upon few things because Jagadish is waiting. I don't want to eat up his time. Looks like I selected something different than whatever I created last night. It should be string input in the Lambda context. Oh, it went to a different world. AWS Lambda. That's also AWS Lambda. Oh, it's waiting for the AWS gateway. Oh, no, 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 it's not that. Okay, let's flip back to this one instead of hunting it down why it is this one. Maybe the template, whatever I've taken, is a wrong template. So let's not waste time there. Let's come back to this one. So this is a simple AWS Lambda, and it has got one function handler, and this function handler, whatever it takes, it converts the string to upper. Now, if you go to the launch settings, you can see that the port, whatever it is using, is this one, and the command name is executable, and the working directory, it is going to the .NET 6 folder within this. That means technically it is going into this bin folder, and whether it is a debug or the dollar configuration, maybe we are executing in the debug mode or in the release mode, it will come into either of these folders based on our configuration over here. And then the next thing is .NET 6. So within the .NET 6, you can see this, the say hello.dll, our DLL, that's what it is executing. And you can see that user profile .NET, so C:/users, and the username, logged in username, and the .NET tools, .NET Lambda test tool. So this is the one which is coming from AWS uh, toolkit. Okay, that's there. So that's what it is coming and it is executing. So when we want to locally test it, so you can click on this. In this drop down, you can see that mock Lambda test tool. Okay, if you don't like this word mock, remove that, and you see this Lambda test tool. Okay, so you change this label here, that will get reflected in this drop down box. So you see that it executes and it opens that nice beautiful tool in the port 5050. Okay, 5050. So you see this it takes up this all this information from the JSON file, which we will see in a moment, and we'll give. I want to show the mistake which I did. I'm giving the string input, and I execute this function. I'm getting this error. The input JSON to string type. So delete this. So you see that JSON document as input to Lambda function. If it is a JSON document, it agrees. Like we saw that in the previous one, but here the thing is that it expects the string. It doesn't expect that object. So see the next part of the sentence. Plain strings must be wrapped in quotes. So that's the mistake I was doing. Okay. So understand what is the contract. Now you execute this. So it will come in here. So you see the name is Srivaru. So that is getting converted into two upper. Now you can go back to that testing tool. You can see that what was the input and what is the output. It's as simple as that. Now you will have this dead letter queue. We'll come back and discuss about this one and executable assembly. So a lot of other things are there, but at least we are getting started with the Lambda functions. We know that how to create Lambda function in AWS console, and how do we create an AWS Lambda function using Visual Studio 2022, and how do we publish. That's the next phase, because there are a lot of small pieces are there. I'm trying to touch wherever I can as quickly as possible within the short time. Again, we'll revisit in the next month episode. So we touched upon what is this one, and there are a lot of things to discuss. So I'm not touching anything over here at this point of time. But again, we'll come back. You can see that let's say hello.NET 6, that is coming from here, the function name. So if you want to deploy this, I will rightmost click on that. It clearly says that publish to AWS Lambda. Okay, cool. Now this is the default profile. That means it is going to my uh, West US, North Virginia, or Ohio, one out of this. Oh, it's going to default North Virginia. It goes here. So the architecture you can select, and how do you want to deploy? This version we already selected. whether you want to deploy zip or Docker image. We'll go ahead with the zip one. Okay, framework, and we'll say, and here it creates it, save settings to Lambda tools default, and click on next. Okay, so it is seconds. How many seconds? You need 30 seconds or 10 seconds, but you can specify. And a lot of things are there. I didn't touch anything. We are using the existing Lambda role, and we can enable these tracings also. We'll see that the dead letter queue and other things which I'm not worried about at this point of time, but definitely we will come back and revisit that. A lot of those things we will definitely revisit. Now, while this is pushing the things, so it has created, there you go. It completed the deployment. Now let's go back to the functions under Lambda. We should see another, you can see that both are zip packages, but you can see the runtime difference. One is Node.js 16x, and another one is .NET 6 C Sharp. Now we'll go into this one, .NET 6 one. You see, here we are not getting editor to work on this one. You see that difference. So that's the reason we fell back on VS 2022. Right, so rest of the things, like you want to test and monitor and configuration, you can come and see this. We don't have the function URL, but that's fair enough. We can test it from here also. We can test it from here also. You want to test something, what we can do is we can come in here, the oh, that should be string. We already saw that. First test, save that. Okay, what is that? 403 doesn't give me permission. Okay, it looks like it got deployed it from here. It's not allowing me, but that should be fine. Fair enough. So where is that tool? It's a local tool. No, it's not local. We don't need local. We need the one which we can test it, the deployed version. So let's do another deployment real quick. Right mouse click on that, publish. I did upload. Let's wait here. Lambda function view. That's the view it should open. What happened to that? Updating the runtime. Looks like it's still updating the package. You can check in this North Virginia. I have all these things. Let me go to the Lambda. Here is that view function. This is the tool which we will get it. But let me see whether it has completed the deployment or not. I'm a little skeptic on that. config setting saves. Oh, okay, looks like it has completed. So let's take uh, one input and just click on this invoke. So it invoked, and you can see that. So let me click this couple of times. So AWS X-ray, you can see this tracing over here, and you can check the logs. um, what are the logs? We didn't configure, I assume, but we can configure additional things over here. But we said 30 seconds should be good enough. So let's invoke this couple of times, and let me come back over here and go to this monitoring. And within this space, in the monitoring space itself, why is this? Why did it log me out? Okay. So again, if I have to log in the meanwhile, I'll give control to Jagdish because I have to get my phone from the other room for two-factor auth. I'll do that. But that's it, guys, for today. So we did quite a few things. We started with Terraform. Why that Terraform skill set is needed? Because that's like a multi-cloud. When you're working in a multi-cloud, that's one of the tools that I'm not telling that definitely you need Terraform, but we liked it. So we were able to create the infrastructure both on the Azure side as well as the AWS side of the world, and we saw the advantage of creating the objects and writing the access control. Still a lot of things to do, but at least we were able to see that, and we were able to create the S3 bucket and expose the static website. We saw that how to access, and then we compiled that Angular project, and that also we exposed it. And here is where we emphasized the multi-cloud scenario. Now you see that the Angular project is in AWS, but the API and database is in Azure. So multi-cloud. I mean, even though this is just a simple hello world, but still it's a multi-cloud. I think so. People will agree. So another one, we started getting into the AWS console and created in the Node.js, and we saw that how to test it and how to write the console logs to find out what objects we are receiving. How can we dig deeper into the weeds, and we expose the uh, function URL, and we tested with that also. Then we started with AWS Lambda and creating AWS Lambda in .NET 6. There are a bunch of templates, but one of the simplest one is which accepts the string, and it comes with the testing tool, and we know that where it installs in a user profile .NET tools. That's where it installs, and we were able to test it. And one key thing is what is the type of object it expects. We need to send the same kind of thing. Like it expects a string, but we were sending something else, and we didn't send with the double quotes. That was it's throwing error. Once we deploy, we can go and use this tool to test the uploaded version or the deployed version. Okay, so that's it from my side, and I will hand over the control to Jagdish. Jagdish, thanks for your patience.
Yeah, thank you so much. That was a nice session. Because so few years back, so when I learned about this infrastructure as a code, so I was really felt like a wow. Because till now, so what we are developing was an applications. So at the later point, so we find a server, we find a path like a mm, FTP. So how do we deploy it? Push the code to that and configure it and everything. So with this, the cloud evolution, so everything was automated, like the infrastructure itself. So writing a code with a few lines of code, so it is creating what are the necessary infrastructure. So it completely automates the entire uh, thing, the process, right? Starting from the infrastructure and doing the build and deployment and pushing that code to a particular specific environment. So in the real time, like the so it helps a lot. So we know the pains, so when we are deploying into the production environments where there are a lot many environments, a lot of configurations, so the typos we do, so and the time we spent so to identify the issues, all these things. So everything was automated and tested it before it going to the production. And this Terraform, that was definitely a good thing. So because it is targeting the multi-cloud, like one language, you can create the infrastructure on a different clouds like Azure, AWS, and GCP. So you know this, so you can create. Of course, they have their native specific thing like a cloud format for AWS, ARM templates for this thing, and Golang for the GCP. So, but
Yeah,
so
like
knowing this common thing,
biceps.
yeah. So knowing this common thing, so you have a wide advantages when people are targeting like a cloud agnostic application. So that gives you a great advantage to you. So I really like this idea. So and it's good to see this how things works. So how easy our life became.
And see the seamless, even though it is just a simple hello world of the application, like Angular 12, .NET 6, and SQL Server, the simple three-tier application, we
Hmm.
split into two different clouds.
Yeah,
So because
exactly.
this is AWS specific, we were speaking about that, but the other side of the world, like .NET 6 and SQL Server in Azure, that's like a black box. We are getting an API endpoint and we are able to access it. So that's a different level. Even though it is a hello world, but it energizes it when we do these kind of small experiments.
Yeah, because Hello World is like our world. So where we start the first step.
That's true. Yeah, you can share your screen, Jagdish. I'll give you a control. I need to go and get my mobile from the other room. For some reason, now I understood. I moved into this flat recently, 1 week ago. So I understood that not to do any sessions from the other room where there was any internet. Okay, cool.
Um, can see my
So
screen, right?
I just flashed it. Okay, cool. Okay, Jagdish, it's all you.
Hey,
Carry
hi
on.
guys, welcome back. So on this Elastic Beanstalk with the AWS, like mm, last month, not before that, I think June. So we discussed about the Elastic Beanstalk. So what is the advantage of it? So I'll give a just a recap of it, like hosting your web applications, so our web APIs. So this is the Elastic Beanstalk is a service which is a platform as a service. Instead, you create a server so where you configure everything like IAS, Apache Tomcat, or Nginx, whatever the thing, and you deploy your application and run and configure this endpoint and you run over it. So this give the added advantages like a platform as a service where you don't need to the underlying configuration, so the easy to virtual machine creation and all those things. You just create this Elastic Beanstalk, so that will give you the public URL, so where you can access it. Where once you deploy the code, so that will be visible to you. So we discussed how we do that and how to deploy that sample.NET 6 application and access to it. Now, in this session, so we specifically talk about deploying Docker container, like the same image. So to the Beanstalk, Elastic Beanstalk, how it works. So all those things we will discuss in this session. Myself, Jagdish. So I was working with IAS as a module lead. So me, Swami, and Anusha, we work together. So in the same team. So there are a couple of prerequisites. So this sessions, like we are using .NET 6, the long-term support, and we are using a Docker. So at least you have some basic in knowledge of the Docker and Docker desktop. So where you want to try it locally and test it like the application is running it properly. So you need to have the Docker desktop in it, and the Beanstalk, like where the service platform as service which is available in the AWS, which do the thing for us. And the software tools we use like Visual Studio 2022. So that's where we run our .NET 6 application, and the Docker desktops. So where we run this test our Docker image at locally, and Python. So because in this session we are using an EBCLI, this Elastic Bean command line interface tool. So where we can run it locally and we can test it, and using those commands we can directly deploy um, to a specific AWS environment. So I hope we know how this C sharp works, web API and all those things. The simple, at least the basic idea of Docker commands and AWS because in the previous session we discussed and we created a user and given a secret key and a password, so where that is useful uh, to run the commands and everything. So this prior knowledge would be beneficial, so you can easily start it. And the technology stack, as I mentioned, using Elastic Beanstalk, Docker, and .NET 6. So this is same so I'm still a learner, so I'm also doing the learning because if you see, so most of my experience on .NET and Azure. So I started to explore, so doing the same things what I'm doing in Azure into the AWS. So if I do any mistake, please apologize me. So and our main target of these sessions, every month, so we are planning these sessions. The target is to understand the things, like instead relying mostly on theory. So we do a practical sessions, like we create a project, deploy it, and we'll break somewhere, we'll find the root cause of it and we'll fix it and we will redeploy it, and that's how we do it, like more of a practical experience. So that is a better way of learning the things, like do it, fail, and and try it again, so and that's it, like deploy it rightly. So that way, so we'll practice everything, so and we can see is how it is happening. So and the practice session, hands-on experience will give them more advantages how it works. So there's a couple of things so we're doing, advantages of Docker, so how to create a .NET 6 and how to create a Docker file and run on the local using a Docker desktop, and executing it or running it locally, and how to install an EBCLI, and how to use those commands to run the image locally, and that and deploy it to the Elastic Beanstalk. Before that, I just want to give the just brief introduction of advantage of Docker, a container. So why people have more love on this thing? So because if you consider, you have designed an application, like so you written as some sample web app application, consider web application. So where what are the things, underlying things will be there. So for example, so you have a virtual machine or normal physical machine. So you will have an operating system and you have respect to DLLs, libraries, dependence, NuGet packages, everything. So that was available. And the final, so the application will be available to you. So all this will be available to you. Consider um, there are dependence libraries, the common libraries, and might be you create a different application where that application might need the latest libraries or the DLLs, where the my previous application doesn't need the latest one, so it is written on top of the older libraries. So there will be, if you update the things there, so there will be conflict. So some of the functionality might not work or completely the application will not work. So at that time, so they have created this virtual machine concept using a hypervisor. So where it will virtualize your operating system. So where you can create multiple operating system on top of it. So how this is like, so you have some 1000 GB disk a machine with a 16 GB of RAM. So you will segregate that like 4 GB to this, 4 GB to this, 4 GB to this. so that you run this application, so it is independent to one another. So all this thing will be available, so there is no conflict to other libraries or the thing. So application will work finely and everything was good. But the problem with this is not the problem. So um, if we see every time we are creating an OS, that's OS might consume like a 2 to 4 GB of RAM, operating system, and the C drive and everything. So other things, and on top of it, we are writing it because unnecessarily we are creating guest OS and the hypervisor and all those things. So with the concept in mind, so what, how the container is designed in such a way that so we have an operating system, either it is Linux or Windows machine, the underlying kernel, so which supports to run these things, so is common for this all these bins and libraries. This is common, so we are using that thing, and so we are running the application, and we are doing a package of it. What are the dependencies of that my particular applications, and we are doing a package it where the common kernel libraries everything, so we are just consuming it operating system. The container engine is like a wrapper on top of it, like, so it will help us to communicate with this the common thing. So this way also, so we package it like we do a simple package where the libraries dependencies which is there for the application one, so that will be packaged and we do that containers in. So when you compare this with this, so we don't have a heavy weight of OS this thing, because the Docker container and images will be lighter, right? So it is faster to build and faster to transmit and faster to deploy it and everything, so that will get more advantages, and we can save more the infrastructure and all those things, and everything works in the similar way, so similar fashion how our application has written on top of it. That's just introduction of this thing. So that is the reason just people are loving the Docker containers or Kubernetes, moving to these things, the technologies. So yeah, we will directly deep dive into so the demo things. So first we will create a sample .NET application. I'll just open my Visual Studio. So I'll create a new project. I'll create a simple web API. So I'll do the ASP.NET Core web API. I'll do next. So I'll change a different path. Local disk, users. So I'll give a name, forecast API. I'll do a next. So I'm not configuring for HDFS. You can enable the Docker. So when you check this box, so by default it will create in a Docker file. You at the later point also we can do it. For example, so I'll remove it now so that Docker file will not be created. So at the later point also we can create the Docker file. So I'll create it. So it will create a sample web API application with the .NET 6. So it have a sample API. So for the weather forecast, there is a custom data so which is written. So it will give the information of that response to it. So our project was created. So give me one more minute so that it will install the necessary NuGet packages for this solution which is required. So So you can run here. So run this application. But as we discussed, like we are planning to deploy this application as a Docker. So you can do this way. Just right click on your project, add Docker support. So you can choose the Docker operating system like Target OS. It is our .NET core, so we prefer to go with the Linux environment. So I'll do this thing. So if you can observe, so there is a Docker file which was created. So if you closely observe this Docker file, so which will help us the what are the required things that is required for running this application. So if you see this, so they are using this image, .NET 6 image. So and the port which is exposing, and it will do the .NET build or .NET restore. That is the usual the commands which will run. So to running this application and do a publish, and so publish and all these things. So it's like a building your project and publishing it. So and it will create a Docker image for you and it will run on it. So to run this, so you need to have a Docker desktop installed on your machine. So sorry. So you can go to the docker.com. So where you can download the Docker desktop for your operating system based on it. So whether your Mac, Linux, Windows, so you can choose what are the things. So I already installed my Docker. So in my machine. So this is the Docker desktop. So you can see this all the things that is available here, the containers and everything. So I'll just clear the everything here so that we can see what is happening. So when we run the application and all those things, it is deleted everything. So I'm also deleting the images, uh, clean up, unused. Why I haven't deleted this image is when you look into the Docker file. So we are using this image to run our Docker in locally. So if I remove this image also, if you remove this, so when you run this Docker file again, it will download this Docker image, and it will do all the things. So to save some time, so I'm not deleting it. So if we delete it, so it will fetch from the Docker hub, so wherever the file is residing. Okay, so now we install the Docker desktop. So what we do now is, so we do a Docker. We just run the Docker and we closely observe so what is happening here. So images and the containers. So if we do the run, so it will create an image. So it just started now. So build, rebuild. So what are the things? So it is creating the respective image. So if you can observe, see the forecast API image was created. So in the containers, there's nothing. So in a minute, yeah, even the Docker is running now. So the application is started. It will take some more time. Just wait for some time. So it's still loading. So if you see this Docker container, so it will give the container which is running on which image forecast API, which is running on 4918. So and this application is open Explorer, so Internet Explorer. So you can see this 49158. That is a port. So which we deployed our and the container which is running and swagger.index.html. So if you try to run this one, so do an execute. So it gives sample JSON response. So the cold bracing hot and the solve information. So we'll stop this and observe what is happening. So although we stopped the Visual Studio, but still the container is running. So let me check that. So I'm using 491, right? And the Docker image, the port 49158, 49158. Okay, it stopped it. Swagger desktop thing is not running. So okay, we will do a stop, delete forever. Yeah. So the next thing is um, I mentioned about the EBCLI, Elastic Beanstalk command line interface, which helps to run uh, the Docker image locally. So for that, we need to install the EBCLI. There are a couple of ways we can install EBCLI. So I'll simply go with the manual installation. So to install EBCLI in our local machine, on the current working environment. So first you need to install the Python, the latest Python version. You have to do the pip. So pip is basically the kind of NuGet package how we do for the .NET applications. So NuGet packages where there is a package that is available in the common uh, place, like public place. So where we get into our solution. The similar way, pip will get the required packages to it. So once the Python install, check for the your pip version and do this command pip install AWS EBCLI, and it will install the CLI. You can check so EB version, Windows runs man EB of the Elastic Beanstalk is installed successfully on your machine. It will give the information about your current version of it. So there are a couple of things you should be keep in mind, like to install the Python and add to the root path. By default in um, the installation, it will ask you to there is a checkbox which will be there. So once you do it, so by default Python will be added to the root path. So if you do this uh, EBCLI, so we need to add this to the our path also, like for the EBCLI. So this is how we do it. So once this is done, so you will find in a path there. So the based on the Python version which you are using, so that might be different. So you go to the user app data roaming Python. So the Python version which you installed. So here it was an example of 37. So in my case it was Python 10. So but this is the path. So this might a bit change a little bit and script. So you add this path to your path. So where you can environment variables to the path file and do it, and you can check using EBCLI EB version. So you will see this version, so that that Elastic Beanstalk command line interface will be available. So using those EBCLI commands, we will run those things locally. So here the ebcli commands were there. So there are a lot many commands. Using these commands we run our applications and all those things. We just will see so how to run those things. So we'll simply go to my Visual Studio, the Solution Explorer, and do an command prompt from this path. You can open a different command prompt or you can do it from here. So anything will works. So, but the thing is, you need just to go to that particular path, the project paths. So it is loading this thing. We'll simply go to this, open folder in File Explorer. If you see this is my forecast API. So my solution and everything was there. And if you observe these things, how the Docker file was written is, so the forecast API and forecast API project. What what does that mean is, like, I have the forecast API, the file path, forecast file path. Under forecast API, I again have a forecast API where I have this CS project. But the catchy here or the tip here is, when you are running ebcli commands, the Docker file should be at the root path. That means in the solution folder. If you go here, just copy this Docker file and put it to the solution level. So you did this one. So now what we do is just go back. We'll just see so what happens if you don't have a Docker file here and try to run this, the eb commands, eb init. So you should specify the application name. So I will say forecast API. So if you observe, there is nothing was there. So if you observe, so there is forecast, the number of folders and the files are there. So just try to do a run. Actually, it should throw an error. So which says that the question is. So yeah, so we are running the ebcli commands. So it is asking for the user credentials. So like so previously in the session, so Swami has shown you that, so AWS Explorer and the profile credential and all those things. Whereas in the previous AWS session, so we created a sample user and we have a secret key and password. So that everything is attached to the profile. So here in my environment, like in my machine, so there are multiple profiles were there. So it is unable to identify which profile has to be taken. So that is the reason. So it is asking me for the access ID and token. So the other way to do it, so use this profile. I use the default one. So it was created. So what it will do is, it will create this folder, Elastic Beanstalk. Just open this one. So there will be config.aml file will be there. So it will have some information. What is the application name and which region? So you want to deploy this application. So in case, so it will give the US West 2. So you can modify whichever the region so you want to specify. So by default, my default profile is pointed to US West 2. So you can modify it at any point. So this is the first step and it is mandatory. First you have to do the init. So eb init -p docker, you can specify the application name. So if you have multiple profiles, so you have to specify the profile which you want to run. So now the next thing is you want to run this as a local eb local and port. So you can give the port name. So I'm giving 5000. What it will do is first it will identify the docker file and it will do an build that. So how when we run this docker the run, so it will executed all this command, it has created an image for us. The similar way eb init eb local run will do the same thing for us, but we got an error. If you see the error, so ebcll cannot find the docker file or the docker run aws json file in the application root directory. So that is the reason we can we need to place the docker file in the root level. So I just placed at the root level. I again run the same command. So it will do the necessary things. It will do a restore, build, publish, and create the image for us, like a forecast. So it started doing the things. Mm, we'll go this Docker desktop and see. So any new images were created. So there are only two images. So this is the Microsoft .NET 6 environment, which is required for to run this .NET application. Whereas this forecast API is when we ran it from our Visual Studio. So it created it. Let's wait for it. So another image will be created. Mm, mm, mm. So there is no container. So it's still in building. It's run .NET and doing a publish. So the still, yeah, you can see there is a new image created. So less than a minute ago. This is the new image which is created using ebcli command. And if you go to this, the application is started running. How to confirm that? So you go to this container, you can see, and you can see the port here. So I have given so this port number, and we will do a test. So swagger index.html, it is not running it. Okay, the the problem here is in the program.cs file. So we said like the swagger and swagger ui to run from the on a is development environment, only in the development environment. So it uses a swagger, but when I run the using the ebcli command, so it will run the production environment. So that is the reasons we are not able to load this thing. So what we will do is we will execute the same command and it will build an image for us. And this time, so we will be able to see the web API with the swagger option. So we'll go to this. So this once we stop at that the command, so the container has lost. So let's wait for some more time. So it again create a new image for us because every time so it will have a newer session, so it will create an image for us. All projects are up to date to restore. Determine a project restore was happening. Up to date restore. All done. Yeah, you can see there is a new image just created less than in a minute ago. So we see whether the container is running. The container is not at run started. So maybe it will take a couple of more seconds. Yes, the container is running. So this time, so we'll try to run this. So we are able to see the response because that is one we do with the program.cl CS where it runs the Swagger only on development environment. When we run using a ebcla command, so it will be the production. So if you command that one, so it will run. You can see this output and everything is working finely. Done. So we are able to run ebcli. You can do control C to stop it. The application will be down. So the container, everything will be lost. So everything will stop. The next part is we create a .NET application. We tested it locally. So there are multiple ways we tested it. Initially, we tested with the Docker desktop. Yes, our application is running and fine. We installed the ebcli and we tested using ebcli tools like a command. ebcli. We first did a ebcli init. So it will create a sample JSON file, so which have a specific information about the environment, application name, so everything. So then we did a EB run command, so where it ran our image at a local. Now the next thing is we have to deploy that to the AWS console. So before going to that, so I just want to quickly show you. So uh, just a second. I'm selecting the environment. Yeah, it is US West 2 only. So I just want to confirm. So go to the Elastic Beanstalk because what my intention is, I want to show you. So is there any environment or anything was there previously? There is nothing. So there is no environments and no applications. There are a couple of applications. So I think we will delete it or we can do it later. As per the environment, there is no environments. When the environment is not there, the application will not run in general. So what we do is go to our Visual Studio. We will do eb create. So forecast API hyphen dev. Eb create forecast API dev is an environment name. So which we will be creating it. Once this command executes, it will create a profile default. Will create an elastic beanstalk and everything. So I'm doing it. So what it will do is, firstly, it will create an EC2 instance. It will create an S3 bucket and it will copy the code as a zip file. You can see the creating application was an archive. So this they're deploying it zip to S3 bucket. So first it will create S3 and the file will be deployed to the S3 bucket and EC2 will be created, and on top of it Elastic Beanstalk will be configured, and later using the Docker file and everything, so the command will run and it will deploy the code to the specific Elastic Beanstalk environment. So it will take couple of times. So meanwhile we can just check so what are the things that were there. So we have verified it Elastic Beanstalk, there is nothing there. We'll go to EC2. So any instance were running, maybe it might trigger the instant. So we will verify it. So whether the EC2 was created or not. We have an Elastic Container Service which is helpful for like deploying the same Docker containers and all those things, but we are using a different approach. So we are utilizing the PaaS services. to deploy this thing. So we have one instant. We will check the what is the status of instant, because you can see that it's pending because we ran the command just now. So it is creating the required environment for us, and require security groups and the load balance and everything. So it is creating on background. So it will just started creating those things. Once everything was done, and application will be up and running. So if you see that it it went from pending state to running state, and we can confirm that our EC2 was up and running. Now it will do us the elastic beanstalk environment creation and configuration. So we'll see. So the environment is also available, but still it is in the pending state because it is also doing a configuration and everything. So it will take a couple of more minutes. So waiting for the ES2 instant int launch, create a cloud watch and everything. So there is a lot of things are happening and doing the configuration and everything. So in a while, so it will create it. So it is doing it. And if you observe the environment name forecast API dev, so we have given the same forecast API dev. So when we running this command, eb create forecast API dev. So what was we given the names with that name only? So in the AWS console, Elastic Beanstalk, this was this is created, and the URL and everything is available. This is the advantage with the PaaS platform as service, whereas all the configuration, so how the hosting, like how we do for the IaaS, Apache Tomcat or Nginx, that we don't need to do all the configuration. For us, AWS will do. So it will do all the configuration and it will provide it. I think when it became okay, so I think the application was deployed successfully. You can check, yeah, successfully launched the environment to this. So there are multiple ways you can open that environment, at least explore that URL. The one thing is you can go to the console and you can access this URL, or you can go here, you can eb open profile default. You have a single profile, so you don't need to mention every time. So I have a multiple profiles, so every time I need to mention it. So with this eb open, so it will open my URL. So at the top of URL there's nothing. I'll do the swagger index HTML. It is loading. My swagger was loaded. I'll do a try it out and execute it. Okay. So I can see the response. So it is same with this. What is there here? Swagger index.html. See, so everything was created. So you can do it a try. And this, so in this demo, so we haven't created the environment like EC2, S3 and everything. We haven't created it manually going from the console application, and we have done it through ebcla commands. If we closely observe, so sorry, how the environment was, like what is the configuration, so what it has selected, everything. So we can verify it. Just go to the forecast API dev. If you see this, this is the platform is on Docker, which is running on Docker running on 64 Amazon Linux 2. Like 2-3418. So if you want to do it manually, create a new environment, web service environment, do a select. So you go the application name, so maybe Beanstalk, application tag, environment name, environment, domain. So so if you see the managed platform, under the platform, you should need to select the Docker, not .NET Core, .NET on Windows Server. You should select Docker because uh, when initially we discussed about how the Docker works, pretty just a second, it is loading. If you see this, the underlying operating system is common for everything. It is not specific to the specific thing. So we are only specifying the environment. We are only specifying which Docker. We are creating that environment as a Docker environment, and we are using Amazon Linux machine. So when we are creating a Docker file, we created a Docker file using a Linux version. So it will create an Linux version Docker file. So if you have a Windows version Docker, Windows version, so you will create a Docker file with a Windows version. So you create that, but Amazon is only giving Linux for the Docker thing. They are not giving the Windows, the system. So the platform version is the only thing. So you can do a create environment. I'm not just doing it because it might take a couple of minutes. This is just to showcase like how we can do the manual creation of Elastic Beanstalk which support a Docker. And we have seen like how we are doing with the manual way, and we have seen like how we do with the EBCLI thing. And so I want to show some more commands. So you already have an environment, you already created, you deployed it, and you made some code changes to it, and you have to do a redeploy it. Instead, previously we have used an eb create. So instead this, we can use eb deploy, which will deploy to this existing environment where we can select the existing environment. So let me show you that, and it will deploy to the that environment. Here if you do the create, it will create a fresh environment. Maybe deploy, it will look out for the existing environment was available or not. It will create. If you don't specify it, the specific environment, it gives us an option. So what are the environments that were available in our AWS console on the specific region? So you can select that, and if it is not there, so we have to do an EB create. If it was there, if it able to find that specific environment, it will deploy to the same environment because it is able to find this forecast API dev environment. It is doing a deployment. So we'll check quickly, go to this environment. See, I just started the deployment, so it is again rotating. So like it is pushing the code, and you can see this here, the application versions. So every time, so when you run this command eb create or eb deploy, what it will do is initially it will do a zip of your solution with the Docker file and everything, and it will create S3 bucket, and it will deploy the file to the S3 bucket. Then it will configure the EC2 environment, Elastic Beanstalk environment. It will deploy. If you see the timestamps and all those things, this is the first deployment. So which we created. You can see this deployed to forecast API dev environment, and it is created in another zip folder. Zip folder. So when we again did a EB deploy, but still it is not deployed. So once the deployment was completed, and this forecast API dev will be there here. This is advantages with this. We can, if something bad happens and somehow the the current version is not working fine, or we have any issues, you can immediately roll back to the previous version. So you can just do deploy the previous version, the successful versions. So you can do all those things. um, if you see this, it is moved from here to here. So this is, now we are using this particular zip file. You can check. So I'm just downloading that. I just want to show what are the things were there. The zip deployment. Let me complete it. Mm, so show all. Yeah, I'll just open it. See, it has our file, the forecast API and Docker file and everything. So simply what it is, it just pulled out everything. Like so, whatever our solution and everything, it pulled out everything. So at the later point, so it ran this Docker file and created an image, stored somewhere, and deployed that on the Elastic Beanstalk. That's how the things worked, and we're able to see the application. So I'll give this deck so where the sample codes and commands is available. So I'll add that on the description on the comment section so that you can refer this. So I'll ask Swami to do that so that you can access this my GitHub link. So or you can directly check my on Jagdish Dev. So my GitHub. So where is 2020 events? So .NET Learner House. Today's date 28/0/2022. So which will have this sample solution and the documents images. So all this thing will be available. So with this, I'll say it as an closure for today, for this month. So the next month we'll be targeting multi-container. Like here we only deployed on a single web API application. Maybe next month the session, so we will be working on like on front end, on back end, on some database. Either we'll take a Redis or SQL, whatever the thing, and we deploy two multi-container deployment to the Elastic Beanstalk. So we'll see how that works, and we will see that. Yeah, thank you so much.
Hey Jagdish, that was pretty good. So I pasted the message in the chat where they can go grab the URL, your GitHub account. I pasted it. So I think that's pretty cool. So we have this. So as mentioned, guys, next episode, it will be more services like getting deeper into the Elastic Beanstalk and as well as from the Lambda perspective. So Lambda with HTTP triggers and Lambda with S3 bucket triggered and Lambda with dropping the messages or records into the DynamoDB. So it's like we are growing as and when we are growing old, we are learning more and more services. How can we integrate with
Yeah, go
this? So
deep into it.
that's yeah, exactly. So that's the thing. So
From
you'll
Hello
see
World to
more of
Hello AWS World.
exactly. So you'll see more of a deep dive slowly, but we'll take baby steps. We are marching towards the containers. Like you see that we introduced with containers and Beanstalk, and similarly the Lambda in containers will go more towards the containerization and ECS and EKS. But before that, we need to have a decent amount of at least a hold on multiple services so that it will be easy once we start deploying bigger microservices into that. The intention is like this year 2022 will touch upon all those services, but 2023 is where we are planning to uh, planning to deploy microservice apps into that. Cool.
And
Anything
it is
else
a
to
cloud
add, Jagdish?
agnostic. So we are planning the cloud agnostic thing. So with the
Yeah,
microservice.
exactly. Whatever we are able to do it in Azure. Technically, we should be able to do it in AWS.
Yes.
So that's, I mean, if not, we'll see that we'll take only those kind of data stores or anything which is cloud agnostic, or we might need to rewrite. We are fine rewriting it. Like one of the example is we have taken Azure Service Bus, and
Hmm.
here simple notifications, different kind of messaging here in AWS world, and different kind of messaging there. Or if you take SQL Server there and DynamoDB here, we might need to rewrite a small pieces, but we'll see that as far as possible to keep it cloud agnostics. How can we do that? Or we'll keep some services in one cloud and use some other services in other cloud. Multi cloud architecture too.
Yeah.
Cool. Thanks, guys. Thanks for joining. See you next month. Have a good and safe weekend. See you next month.
Yeah. Thank you, guys.
Bye.